They're very excited to be here on a Tuesday, rocking meetup live stream number 85 of the DoK Kubernetes community. This live stream has been building up for a while. I'm going to say even maybe 6 months. I'm trying to think about the first time that I talked to Salman. I'd have to check my calendar to see when that first happened, but very, very happy to be here. As usual, welcome everyone to the DoK Kubernetes community. If you're new, some really easy things for you to do. Smash that subscribe button, get in our Slack, follow us on Twitter, check us out on LinkedIn, do all that good stuff. Also remember that we have our upcoming event in KubeCon on October 12th, all right, our co-located event. I will be putting the link to that here in the chat so that you can sign up already. So that's there. But don't worry, we'll have the speakers announced this week so that everyone's more aware of the kind of content we're going to be having. I've got a lot of really exciting stuff that's going to happen. A special surprise speaker that we were able to get last week on Friday through some very interesting dynamic movements on Twitter. But anyway, as a reminder, we are the DoK Kubernetes community. You will always have a place here to help learn about how to work with DoK Kubernetes. Today's speaker is an awesome person. First of all, I'm just going to start with the name. And I just found out as well too about the first name. Salman means peace and Iqbal means prosperity. So today we got best of both worlds. We got peace and prosperity. Can never have too much of that. Salman, welcome to the DoK Kubernetes community.
Well, thank you very much. I think it's fair to say this is probably one of the best communities around. So thank you very much for welcoming me. And I apologize. It's taken me a little while to get here, but here we are. And, you know, we're going to have a great time. So thank you all very much, Bart, and all your colleagues and the community who welcomed me so much, made some kick-ass raps that you always make, Bart, and everything else, and the tweets. I am very excited to be here. And indeed, my name means peace and prosperity. But today we're going to be talking about what happens when you lose a cluster, not when it's not so peaceful.
And not so prosperous either.
Yeah, not so prosperous. That's exactly what we're going to talk about.
And an added ingredient on there, well, just a couple of things. Your name on Twitter is Soulman. Where did that come from?
Yeah, definitely. And I think there's a question here from Luke. I think it says Soulman is a soul singer. I'm definitely not a singer. And please do not ask me to sing. It's just Salman Iqbal is quite a common name in some parts of the world. So there's quite a few Salman Iqbals out there. And when I joined Twitter, I couldn't get Salman Iqbal. I mean, I could get Salman Iqbal 65421, but I was like, it doesn't make sense. So my friends back in university used to call me Soulman, and I was like, oh, maybe I should just do Salman Iqbal. And it was available. And yeah, I just started with that. So if you search Salman Iqbal, many pop up. If you search Salman Iqbal, I think there's only one. Unless, Bart, you want to take that name.
There can only be one. Not that there really is one. There can only be one. That's good. So now we got that background down. Tell us a little bit about yourself, about technically speaking, how you got into Kubernetes, and then we can start angling more to what we're going to be talking about today.
Absolutely, yeah. So my real name, as Bart says, is Salman, but it's fine. You can call me Soulman or Salman. So I got into Kubernetes. Maybe I'll start. I come from a developer background, so I studied aerospace engineering. Somehow ended up working in Kubernetes, but it's wherever the road takes you. So I was working as a developer, working as a cloud developer. But I'm going to say about 3.5, 4 years ago, I got into one of my really close friends, Lewis Denham Parry. He is a co-organizer with Cloud Native Wales. He's basically introduced me to containers and Kubernetes, and we started going to meetups. We started our own meetup in Wales. I'm based in Wales. West Side represent, as you were saying on the rap the other day. From there on, we started migrating our workloads to Kubernetes itself, and I ended up going to Austin in KubeCon, and that was great. And I think that was really the springboard. And from there on, I worked with amazing people within our community. I got in touch with Daniela Polencic, who is LearnK8's founder, and the one-man show. And I worked with him quite a lot, doing some training stuff. So yeah, I've got experience of running workloads in Kubernetes for the last, I'm going to say, 2.5 years. It definitely feels a lot longer. I'm not sure why, but it definitely feels a lot longer. But I think I'm going to say 2.5, 3 years. And then I started doing Kubernetes training by LearnK8, which I've been doing for the last, again, the same 2.5 years, perhaps. But currently I'm working right now with Appvia. It's a cloud consultancy company. And what I do, my role is MLOps, which we'll talk about in a sec now. I'll give a bit of background, but yeah, everything to run on the cloud and Kubernetes, that's what I do.
Very, very good. Now, you mentioned your experience as a trainer. What are the common problems that you see that folks having? Because it's no secret that Kubernetes is challenging. There are difficulties around that. If you can give advice to folks that are out there that are that are learning this stuff, and I think everybody's learning this stuff when it comes down to it. I was talking to somebody about that earlier today. How many true experts can you find on something that's constantly evolving? But what would your recommendations be for folks that are out there, not just maybe in terms of resources, but what are the real common problems that you've seen as a trainer?
Yeah, so I think that's a very good question. What was the real common problem? And I think, just going to go with my experience, I think, especially when people are starting out, I mean, when people are starting out, there's too much, right? And there's a lot to take in, and you perhaps don't know where to start. And when you do start, what are the things we need to be doing afterwards? Now, of course, we know that there's tons of material out there that you can follow, but I think the best piece of advice I can give is talk to people around you, join communities. I know it sounds like we're at a meetup for DoK, and I'm talking about DoK, but that's honestly the truth. And the way I learned about all of this was from our meetup, Cloud Native Worlds. And I just talk to people around you, talk to people on Twitter, join the DoK community on Slack or other communities on Slack or wherever they are, and ask them like, oh, I'm starting up, what am I doing? Even post on Twitter. A lot of people, there's tons of people out there on Twitter, like Bart, yourself, and David, and there's so many people out there who are helping out. And I can see Simon's there from Cloud Native Islam.
Yeah, shout out.
Simon's always helping out people, and he's just pointing them in the right direction. Yeah, so I think point is, there's a lot, of course, but my key takeaway is, talk to people around you. Go to meetups.
I think that's great. Is that don't see it as a technical problem, see it as a people problem.
It is a people problem.
Get in touch with the right people. That's it, and learn in public. Yeah, I think that's a really good point. That's a great point. Sound advice. Awesome, Salman. Well, with that in mind, you can jump right into your presentation. As a reminder, folks, if you have questions, put them in the chat. We'll get them answered accordingly. If you don't know the time, we can take it to Slack. But this topic in particular, I lost my cluster. Is this something that you speak from experience? Have you ever lost a cluster?
Absolutely. Okay. Definitely did not do it on purpose, but sometimes happens. And the point of this talk is just to show you. I think it goes back to the point like, once we start, you can get started and everything's good. But people call this day 2 operations. Once everything's up and running, what do you do? Like, how do you make sure you've got your policies and your procedures in place for if anything goes wrong? How do you go back to it? And what things you need to consider and what you need to do. So I think, that's basically the talk. Comes from experience. And also while doing training, people do ask this quite a lot, because the mind shift, there's a bit of a mind shift from what you used to do before to what you do now in Kubernetes. And hopefully we'll touch upon some of the topics that you might find interesting or boring, depending on how you look at it.
Certainly not.
But yeah, please feel free to drop your questions in. Bart, if I miss a question, please have a look at it. Just let me know, and I'll jump right in. Anytime anything's unclear, just let me know. Please, people on the chat, on the stream. I haven't made a massive presentation, but hopefully we can have a discussion, and I won't bore you to death.
Oh yeah, and quick shout out as well too, talking about discussions. If you want to see Salman live again next week on September 15th, he'll be speaking in KCD UK Kubernetes Community Days. Awesome event being put on by awesome people. Massive shout out to Matt Jarvis for all the work he's doing there and all the other folks involved in the organization. I put a link in here already. We'll put a link at the end for folks who arrived a little bit late. But just keep that in mind. That's happening next week. It's absolutely free. There will be very, very good talks, and Salman is one of the speakers that'll be involved there. So just keep that in mind.
Absolutely. Yeah. Thank you very much. Thanks for the plug, Bart, because it's absolutely free. There's workshops. Well, we'll talk about it now. And I have a slide, and I shall drop that slide in.
Do it.
Excellent. So let me start my sharing. Make sure we get the technology working correctly. So I think this is right.
Yep, you're all good.
What are we saying? Are we good?
Yep.
Excellent. So thank you very much, Bart, for an amazing intro. I love the energy from the community. I honestly really like that. And thanks everyone for joining in. So we are going to be talking about Kubernetes backup and restore. Just a little bit about me. Who am I? My name is Salman Iqbal. Currently, I work as an MLOps engineer at Appvia. So all I try to do is try and run machine learning workloads. I say all I try and do. I try and run machine learning workloads in the cloud in the most efficient manner. So it could be running in Kubernetes or outside Kubernetes. So that's what my day job is. And I have worked in a number of organizations. I work within the UK government, outside the UK government. Currently, I'm working with Bank of England. I have worked in finance. I have also worked in the aerospace industry. So I have a varied background. I actually I am a developer. So I come from a developer background, but I've been doing Kubernetes training and working with Kubernetes for the last 2.5, 3 years. Also, I work as a Kubernetes instructor for Learn K8. Shout out to Learn K8. Beautiful blogs from all the people from Learn K8. You can check out Learn K8 if you go over to learnk8.io. I think one of the things I'll plug in now, because we're on it, we'll talk about it a little bit later on. Just today, fresh, hot off the press, the first demo. This is, we like to make sure that we know where we're spending our money, of course, and we want to know how we are very efficient. And the way we do that is by reading on Kubernetes pricing plan and trying to figure out how much is it going to cost me per pod. It's very difficult to do, but the people at Learn K8, Daniele and a couple more have worked on this quite hard, quite intensely for the last few weeks and a couple of months, and to bring you a calculator. I'm going to drop this. I'm going to drop a link to this in the chat so you can play around with this. But the point is, this will give you cost per pod. So if you have a cluster configuration, it will tell you how much each of your pods are going to cost you. This nitty gritty. You can do it for AWS, GCP, and Azure. There's a lot of information in here, but I think I'll just drop in hot off the press.
Do it.
I'm going to drop that. That's the first demo. At the end of the we'll talk. At the end of the presentation, we'll talk about it. But anyway, that's there's tons of blogs in here you can check out. It's in. I've pasted that in. Yeah, that's me. It's the Learn K8. I've done training all over the world, and I love doing it because I learn a lot. Actually, I learn a lot from training itself than from doing it. Also, I'm part of the Cloud Native Wales and the Cloud Native Islamabad. That's Simon is on there. Community. We started this community to make sure that we were having right discussions around cloud technologies within Wales, and it's been going strong for the last, I think, 3 years. Next week we are doing this Kubernetes Communities Days UK in collaboration with other meetups. You can find me on Twitter at Soulman Iqbal. The name as we were discussing earlier on. Yeah, so you can just head over to Twitter, and that's probably the best way to reach me. I'll talk about it in a second. I have to put this in because Appvia we are hiring people. It's just a slide that I have to put in. We're looking for Kubernetes engineers, Golang engineers. If you're interested, it's a pretty cool company to work in. And just drop in, take a screenshot of the slide. Drop in recent email. You can head over to the Appia website, appvia.io, and have a look at it in more detail. But basically, we're hiring. If there's something you see that's not there and you're still interested, please drop Reese a message, and he'll let you know. Another place where you can get me, where you can find me, is on YouTube. So I started a YouTube channel a while ago, and I haven't updated I haven't uploaded the video in a little while, but here we are. If you want to find me on YouTube, you can just search Soulman Iqbal. I make short videos on Kubernetes, just trying to explain some of the concepts, and I'll really appreciate if you could like and subscribe, as they all say. And everything on there will be. I'm going to be uploading more videos before the end of this year. There's quite a few. There's a couple of series coming up as well. So just big shout out to Kubernetes Community Days UK. It's a free 2-day conference happening next week, 15th, 16th of September. I think it's UK time, so 9 a.m. here till I think 3 or 4 p.m. So hopefully you can catch some of it, and it's completely free. And there's a lot of talks on Kubernetes itself and the cloud native landscape around. And also, I'm going to be doing a talk next week on exactly what Bart asked me, which is, and he summarized it quite well, that the problems that we face today can be solved if we talk to people around us and learn from them. And I'm going to be talking about how community is more important than technology, because technology changes all the time. The only thing constant is that we have community. So that's what I'm going to talk about. But there's amazing workshops and talks, and it's completely free. kcduk.io. Bart has already dropped in a link inside. But that's all the intros done. So what is the fuss about what we are trying to achieve here? What's the fuss about backups and restores? We've got a Kubernetes cluster which is running all the things correctly, and I don't see a problem. Everything is fine, but what's the fuss? Like, I need to make sure I can do backups. Like, for example, something happens, a meteor strikes your data center, or something happens, or like me, doing something that you're not supposed to do, and you delete your cluster by mistake, or delete your configuration, or delete your application by mistake. That can happen. Mistakes happen all the time.
I can only speak to the meteor strikes, which happens once, twice a month for sure.
And you could be unlucky. A meteor strike could, end up on your data center. It could happen, right?
Could happen. Yep.
Could happen. But more likely, it's people like me managed to delete something that they shouldn't have deleted because, we just too trigger happy, running lots of commands. But yeah, it can happen. Or somebody can do something and maliciously delete your data, your applications, your configuration, your cluster, everything is gone. Or perhaps, again, this comes in disaster recovery. You need to do something like, as in, you've got some other problems within where your servers are, not just in a region. You need to move from one region to another. And maybe your Kubernetes cluster has gone into a state which is not really recoverable. It's what we're going to call a corrupt state, something that's happened. You can't really roll back your releases. You can't really roll back your deployments. Something's bad has happened, and we want to get back from it. So before I talk about how do we do this backup and stuff, I think it's important to just have a super high-level view of what Kubernetes components are. And I'm sure all of you are very well aware of what the different Kubernetes components are, but I'll just lay it out really quickly, all together. So in a Kubernetes cluster, you usually have a number of machines. So we have some nodes, and they could be of any size. They could be big, small, as long as they have memory and CPU, they can form a Kubernetes cluster. And what we usually do is we pick one or a number of machines to be in charge, and we call them the control plane. So the one on the right that you see with the Kubernetes logo is the control plane, and the two on the left are the worker nodes. So the control plane is in charge of deploying all our workloads, and the components that get deployed, the workloads, which are our applications, they get deployed in the worker nodes. So I have a cluster that looks like this. And in order for a cluster to exist, I need to have some Kubernetes configuration, some components that run in Kubernetes themselves. I have some applications that are running in, and we'll look into a little bit more detail on all kinds of applications, all kinds of jobs, all kinds of deployments, secrets, whatever it might be. And I also might have some data that's running in the cluster. So this is usually the landscape. You have some configuration of your cluster itself, where it's running, how it's running, how many nodes I have, how big are the nodes, and all that stuff. And then on top of it, I have the applications which are running inside a container in deployment, stateful sets, whatever they might be. And I also have some data, and we'll talk about different types of data in a little while. So that's fine. That's okay. That's a super high level, but just a little bit more, just a tiny bit more information, which I'm sure you're all aware of. And then we'll dig into, it's important to understand some of the components, because we're going to dig into one of them in quite detail. Imagine I need to deploy this red website, right? It's just a simple website, and all it does is it serves a red page. And this page you'll see on my Kubernetes videos quite a lot. It's just a static page. It doesn't do anything. All it does is a static page. And I can deploy this in a Kubernetes cluster by expressing this in a YAML file. So this is my deployment YAML file. I'm sure you've seen quite a few. You're probably sick and tired of seeing all these YAML files in your life, but here we are. This is a deployment file, and all the deployment file is a recipe for how many pods I like to deploy in my cluster. As in, or in a pod, I have a container, how many containers I'm running inside my cluster, how am I running my application. In this case, you can see in here at the bottom, I have containers name, and I have this image, learn KX, right? That's the container image that I like to run. And I've got some more information in here. We've got replicas too. So anytime I need to submit this to a cluster, I can take this YAML file because it's everything's written in the file itself, and I can submit this to a cluster using kubectl if I wanted to. Right? Now I have this command line tool at my disposal, so I can perhaps use that kubectl apply -f deployment.yaml and submit that to the cluster. I mean, I can deploy it from a pipeline or anything like that. I can submit it to a cluster. Now, once that goes to the cluster, that request gets received by the API server. API server receives that request. It takes that request. You send it as a YAML file. The kubectl converts into JSON. API server receives it. The API server does a lot of things inside. If you want to know a little bit more about what it does inside, check out my YouTube channel. But it receives the request, and all it does, it parses it and then sends it over for it to be saved onto a database. Because we've got this information that we need to set this configuration that we want the cluster to eventually have. And that gets stored in the database. And that database is etcd. And we'll talk about etcd in a little while. And that information gets stored in etcd. Etcd is the most important part, and this is where everything from backup comes in to start with. I'll just mention a couple of other things in here. Once information about what we're trying to deploy gets stored in etcd, it's by what pod are we trying to deploy? What's the name of the deployment? How many replicas do I need? And then we have this controller manager that kicks in and says, oh, you're asking us to deploy 2 pods, so I'm going to go in and create you 2 pods within etcd. And then we have another component called the scheduler, and the scheduler kicks in and looks at all your worker nodes that are running in and picks one of the nodes and deploys it on there. So it just picks one node. And how do we actually deploy a workload? Just to give a full picture and finish off, there's a component called kubelet that runs on every worker node. It's just a binary that runs on a worker node. And the point of the kubelet is to talk to the control plane via the API and ask the API if it has anything for it to run on the worker node. I've got these multiple worker nodes. The scheduler has decided it's going to deploy one of the replicas on worker node 1, which is on the left, and another replica on worker node 2, which is on the right. So it's going to pick one and it'll deploy to one of those. So, but what kubelet does, it talks to the API server, which in turn gets that information from etcd and deploys it inside the worker nodes. Now, this is the crux of all backup and recovery we're going to talk about. So etcd is a database, and it works using a RAF protocol. And what that means is we run it in a cluster, and there's usually you run it like n+1/2, and it gives you what that means is if I have 3 clusters, 3 instances of etcd running, if one fails, we can still keep operating. And if I have 5 etcds running, if 2 fail, we can still keep operating, as long as they agree on what the value gets written in. And what is etcd? It's basically a strongly consistent, which means basically the global ordering of events is very consistent. So what came in first, what came in second, and what happens is after we write from one client, after we write the value to one of the clients, another client won't ever see the data before writing it. So basically, what happens is everything is consistent. Everything gets synced across all of these nodes, and it's designed to be run as a distributed system. Unlike traditional SQL databases, SQL databases, they just like run on one server. etcd is designed from ground up to be run with multiple nodes, and it's particularly designed its design allows us to run for high availability without sacrificing consistency, which is really important. And it's just a key value store. And all that does is, unlike SQL databases, etcd data model is straightforward. All it's got is key and value. There's no relationship instead of arbitrary data relationships, between one table to another. This helps it ensure relatively predictable performance against SQL. And this is where in etcd, where all the information about the apps gets stored and the state of those containers or the pods that are running in. Everything goes in etcd. When we do kubectl get pods, as in give me the information about the pods, we can go in. It goes via etcd and pulls it out from there.
We got a quick comment.
Yep.
Someone saying that means we need to make various clusters of the same type.
As in, I'm just wondering what that actually means, Avanish. Is that various clusters of the same type, same type of work nodes are we talking about?
I'm assuming so.
All right, okay. So if that's let's answer it. If it's incorrect, Avanish, please ask the question again and we'll answer it. So if I have a cluster, in the cluster, I can have worker nodes of any type. As in, first of all, I can have normal CPUs, I can have GPUs, I can have TPUs, and I can attach them all together, and that I can run that as one cluster. That's no problem whatsoever. And I can have machines of different sizes. I can have like a smaller machine or a bigger machine. I can pick anything I like from AWS. I can pick like A1X, 2X large, or A1 medium, or if you're in Azure, you can pick like B12 or whatever, A7. So I hope we answer that question. If we don't, please ask again, and we'll try and answer it. But please do let me know if the question comes up again.
Yep, no problem.
Okay, cool. So all we got is a cluster, and the cluster could be of multiple worker nodes, or you can just have one worker node. And what we got is etcd, and etcd is the thing that stores all the information about the apps, what's running, what's the state, what is the state of a cluster gets stored in etcd, and it's very important. If you want to read what's in etcd, it's basically you get this command line tool, etcd-ctl, and you can start writing your own values. So in here, I can do a put on key and a value, and in this case, we're doing foo and bar. So foo is key and bar is value. Of course, we've always got to do foo and bar. And if you want to read the value, you can do etcd-ctl get foo, and you can see, and it will read it and read the value for it and say, yeah, this is the value. I mean, it prints up foo and bar again because it prints like key and value. Right, I think Avanish has asked, has replied, what is the meaning of strongly? Oh, that's a very good question. So basically, strongly consistent is that the events, the order in which they happen, they basically, after we write from one client, after a write to one client succeeds, another client will never be able to see a stale data before writing it. So if one node has succeeded in writing new information, none of the other nodes will see any of the stale data. I hope that answers your question. So basically all we're saying is anytime you read anything new, it's basically fresh information. If there's a little caveat, if all the nodes agree that the value that you're writing is correct. I hope that answers your question. So let me go back. Right. So all we've got is etcd, and we've written all the values in etcd. Everything about our cluster is in there. Every time a pod gets deleted, it gets updated in etcd. Every time a pod gets updated, we update the information in etcd. If it moves from one node to another node, we update that. And all the information about services, about ingresses, everything that we submit to the cluster gets stored in etcd. Now, sometimes what happens is we're running stateful workloads, as in, I've got this container. Usually in Kubernetes, we run stateless workloads. As in, if I delete a container, it doesn't matter if anything's if it's in the middle of the process of doing anything, we'll just come back on and continue as if nothing's happened. The stateful workloads, it could be that I have an application that's running and it's writing to a file. And if it's writing to a file, if it crashes halfway through, you're in a bit of a trouble. How do we recover from that? And that can happen. So imagine I have this red app at the same time, and all it does is every time the person logs in, it takes the information about who's logged in, from where, and writes it to a file. If the container crashes, we can lose the data that's inside it, and I'm sure you all know that. What we can do instead is we can have an abstraction of a volume. So volume is where we write data. And a pod can use any number of volume types simultaneously. because volumes could be different, and we'll talk about different volume types in a second. And volumes have lifetime of a pod if we just work normally. So if the pod crashes, the volume is going to disappear with the pod. But what we do want to do is have what's known as a persistent volume, which will exist beyond the lifetime of the pod. So if the pod crashes, we still have this volume that's existing, right? So the file that we're writing to, that still exists. So when a pod ceases to exist, Kubernetes will, right now, if we don't have this abstraction, if a pod ceases to exist, well, Kubernetes will destroy the ephemeral volume. However, what it won't destroy is if we have a persistent volume. And we'll talk about persistent volume is just an abstraction. And for any given kind of volume in a given pod, data is preserved across the containers if it restarts. And at its core, I think if we just talk about generally, a volume is just a directory. That's all it is, right? And I'm sure we all agree on that. Possibly with some data in it, which is accessible to the containers in a pod. And how that directory comes to be, and the medium that backs it, and the contents, that depending on the type of volume that you use. Because right now I can go and store data if I wanted to. If I'm on Azure or if I'm in GCP, I can store that in a storage bucket. I can storage in a blob in Azure. If I'm AWS, I can store in a block storage. I can pick any other type of data. So all we've got is basically what we want to have is this abstraction of not writing the volume inside, but having this thing called a persistent volume. And a persistent volume is basically an abstraction that allows us to write to any different type of volume. And what are the different types of volumes? Kubernetes offers you several types based on what you're doing and what provider you're going to be running your Kubernetes cluster on. And I'm going to stick some of them here. So if you're in AWS and if you want to write a file to one of the storage options, you've got CephFS, which is cloud agnostic. We've got Azure Disk, Azure File. AWS has some. On the other side, there's some specific ones in here: host path, Gluster FS. We'll talk about the claims in a little while. But basically, what we've got is a number of options to be able to run volumes. How are we all doing, by the way? Are we still good? Or is everything still clear? Just let me know in the chat. But are we doing good?
Very, very good. Nice. Because we've had a couple of talks about persistence volume, but I think it was explained very, very well from this perspective of understanding why you're going to do this. Because if a meteor strikes, or if somebody gets hacked, or if a data center has some other kind of problem, what are the kind of steps that they want to have in place beforehand so that they don't run into a situation where everything just disappears?
Yeah, absolutely. I think we've got another question on executing ML workloads. Is there some sort of topology aware mechanism used in terms of the IO operations on the nodes? All depends on what kind of workloads you're running on. I think it's the same. It doesn't matter if it's ML workloads or normal. We'll talk about ML in a second, but let's just talk. I'll answer your question in a second. And if you're running ML workloads or just workloads in general, if there's any topology we should be aware of, we're going to discuss that. But in terms of ML workloads, depends on what you're doing. Let's say you're just running a normal, a batch job. And all it does is runs at nighttime. It's got some TensorFlow logic in it. And you can just run that normally as a normal deployment. But you can, run stuff in a GPU, and the way you mount a GPU is slightly different. I think there's no specific thing as to this is one answer, depending on what you're doing. So Kubernetes, you can run a lot of ML frameworks on top of Kubernetes. You can run, depending on what you're doing, you can run Kubeflow on Kubernetes, you can run Apache Spark on Kubernetes, and all that sort of stuff. Depending on what you're trying to achieve, is then you have to kind of pick one topology of what you're doing. But if you have a bit more specific questions, let me know. But I think in terms of IO operations on the nodes, you just have to be a little bit careful. For example, imagine you have a pod that's running, and let's say you're writing to local storage. Let's say you're writing to local storage, and storage exists only on that node. If that pod crashes and restarts and ends up on a different node, we're screwed, because what we're writing is in a different node, not on this node. So I think what you have to be is you have to be a little bit careful of which solution of storage you pick, and that's why we have these tons of options. Let's say you do local host, right? And local is going to give you that problem. So yeah, depending on what you're doing, you just have to be careful in like what kind of solution you pick for your workloads. I hope it answers it. I think I did go a bit roundabout in a second, but let's go ahead. So what should we back up? What we need to do is we need to back up anything that's running in etcd. We get anything, all the information that's stored in etcd. Perhaps some of the configuration files, stuff like our Docker files, our YAML files. We don't want to lose any of that stuff. If we lose it, perhaps we can bring it back. Maybe some of the the images that are running in the cluster. So containers are running in the cluster. In dev environment, I might have a different image running than in production environment. If I lose the images, I need to be able to get them back. Perhaps I can rebuild them or whatever I can do. What else do I need to look out if I need to take a backup? Is maybe a database. I need to make sure I back up a database. Also, if I have any volumes, we talked about volumes, and maybe if there's an infrastructure, that's there, I need to make sure I can back that up. And we'll cover the infrastructure first. But what we got here is a number of things. Like we've got etcd that stores all of the information about the state of the database of our cluster, and we've got some configuration file. We have some images. Perhaps we're running some databases, and that is where we're going to talk about. Should you run databases in Kubernetes? We'll have a little bit of discussion there, and then persistent volumes and infrastructure. And if, in my opinion, if we consider all of this stuff, we can think about if we should back up or not. Maybe let's take the easiest bit in consideration first, and let's start with infrastructure. I'll start. I know that was last on the list, but we'll start with that one. Oh, cool. But fair enough. I think it looks like we've answered your question. Imagine you're running a Kubernetes cluster anywhere. So this is I got this diagram from Databricks. You're running this in GCP. You have a Kubernetes cluster that's running in GCP. Of course, you need to create one. In Kubernetes, if you need to create a Kubernetes cluster in GCP, you need a project. In there, you need a cluster. You also might need, like some account stuff. So IAM permissions and all that sort of stuff. You might have to create some users. You might need some external services like cloud container registry, cloud storage, Stackdriver for any of the logging and monitoring. You might even need a NAT that's going to allow your workloads that are running inside your cluster to talk to the bits that talk to the bits on the internet. And you might also want to have multiple zones inside the Kubernetes cluster. So there's a lot of configuration that goes in. So there's options, right? So you can either go in and create it from the UI manually, or you can do what you all hopefully are doing or looking at doing is use infrastructure as code. What we make sure that everything is written in code somewhere. It could be anything. It could be Terraform, could be Pulumi, any of the. You can even write Bash scripts, whatever you like or you'd like to write. You can use that. So if you lose the infrastructure that created your cluster in the first place, you can take those scripts, you can kick off your pipelines, and they can go and create your cluster. And perhaps you create a cluster using Kubespray, maybe you create a cluster using KubeADM. You can go ahead and create it from there. Why do we use IAC, infrastructure as code? I'm sure you're all aware of this, but really quickly, it gives you consistency to make sure that everything. When you recreate your infrastructure from when you lose it and you create it again, you've got this consistency from before. You haven't lost any of the permissions. You haven't lost any of the things. It's quite quick to create stuff. You don't have, it allows for faster execution when configuring the infrastructure, and you can, gives you a bit of visibility and helps other teams as well. People can copy your code and apply it elsewhere. And if you don't have to do any of the manual intervention, you can reduce the cost, hopefully. And you can reduce risk if you're not doing anything manually. And more importantly, you can scale out. If you wanted to scale out and change things and do more or do less, you can do that. But, if I have my scripts, I can take the bit that I need to do. If I lose a cluster, if I lose my infrastructure, if a meteor strikes the data center, as Bart was saying, we can grab our scripts again, run them, and basically recreate our infrastructure from scratch. But that infrastructure is fine, but that doesn't give us our workloads that are running inside the cluster. All we've created is a plain blank infrastructure, right? Things have gone wrong. We've lost everything. Maybe our project got deleted, our account got deleted. So, but we have these scripts which are stored somewhere inside in GitHub, and we can pull them up. So the next thing is, logically, we'll say, oh, maybe we should have a look at what's inside etcd and see if we can back up, because we said the state of the database lives in etcd. And if I have a backup of etcd, perhaps I can restore from that backup and get everything back. Sounds like a great idea, and I'm pretty sure you're all aware of, right? So I have this key value pair database that's running for our cluster, and all it's doing is all of the state is inside the cluster, right? The whole state is in the cluster, and the snap basically what it does is if I lose all the nodes, I can create like a snapshot of the database, and all the Kubernetes states and all the critical information can get stored, and I can keep and I just need to make sure that I encrypt the snapshot files. I can use what's called a built-in snapshot. So I can use etcd command line tool, which is called etcdctl. I can run this command if I have access to the Kubernetes cluster. I can run etcdctl snapshot save, and I give it a name. I can call it db or snapshot db, whatever I call it. I'll just create me a file called snapshot db, and we should, wherever you create it, it will be in that directory, and that will include your state of a cluster at that point in time. And what you can do is, if something goes wrong, you can restore your etcdctl. Let's say you got a brand new cluster. You just have to make sure you save this file in a location that's not inside the cluster, right? Maybe it's in a bucket somewhere. Maybe it's in a different machine. Maybe it's somewhere else. And you can restore easily using etcdctl snapshot restore db. And all we've got is we'll go back to, hopefully, where we fully were. We'll talk about a bit of some of the limitations in a second. And if etcd is running on a storage volume, because you can do that, that supports backup, such as let's say you're running an Amazon Elastic Block Store, you can back up etcd data by taking snapshots off that volume. And if you're using a different volume, you'll have different capabilities. If you're using a volume from AWS, sorry, from GCP or from AKS, all these volumes have some sort of snapshot capability. So you can take snapshots of these volumes as well. So you got two options there. Now, so how do we restore from the snapshot, which is we just said? You can do etcdctl snapshot restore db. And what you can do is you can use snapshots version, their version. So you got major, minor, and patch. And you can just like restore from a different patch version as well. So it just allows you to do that. What else can you do? I mean, I've got this command that I need to run in etcdctl snapshot save. What you can do is you can run that command as a cron job. And if you run it as a cron job, it's basically running a script every whatever the cron setting you got it on, and it will take the snapshot of the database and save it where you wanted to save it. And managed Kubernetes offering differ from one to another. So imagine if you're using Amazon AKS, Amazon's Kubernetes service, or AWS's offering, or GCP's offering, or anyone else's offering. The ability for you to take snapshots will differ. And the point of us using a managed service is so that we don't have to, look at all these snapshots and take snapshots of etcd, and we'd hope that it will give us high availability. But for example, in GKE, you can. So in Google Kubernetes offering, you can back up the etcd snapshot by getting the pod is kube etcd-o, and you can check the version, and you can run the commands like you normally would, and you can basically you can take a snapshot. But Google actually do not recommend restoring from backup files unless the cluster is completely broken. So, you know, it's not like, depending on where you're running your cluster, it's not what's happening. So some limitations. This process, depending, so this is a bit of a generalization, depending on where you're running your etcd, depending on where you're running it, usually this procedure does not back up any application-specific data. So, I mean, you've got some configuration files that might not back up those. It doesn't back up your persistent volumes, and that's a bit of a problem, right? So that's where all our data might be living. Depending on when the snapshot was taken, you know, you could be taking snapshots every, I don't know, every hour, maybe every 6 hours, maybe every 10 minutes, maybe every 5 minutes. Any workloads that were scheduled after the backup was created won't be restored, but that's correct for every kind of backup, right? So you have to kind of consider how often you back up. And sometimes, most of the times, imagine you're doing an upgrade and you go into a state which is very tricky, sometimes it's kind of hard to restore the cluster from a failed upgrade. So you might have to try and just fix that problem rather than try and roll back. So I think the lesson there is, if you want to do that, try that in dev environment first, then in testing environment, then production environment. And the procedure is not intended to restore a deleted cluster. So, you know, you can't restore a deleted cluster. As we said, we have to basically bring back infrastructure. And so basically in etcd, we have some limitations. How are we doing, Bart? Are we doing okay? I just want to make sure you can still hear me. Was that? Oh,
fantastic.
good.
Yep.
Okay, cool. All right, any questions, please throw them in. I'm keeping an eye on the chat. So let's take a stock of where we are. We've decided, we've figured out we can talk about infrastructure. We can kind of restore from infrastructure if you wanted to. We've got all the configuration files written as infrastructure as code, so we can bring them out, run them in our pipeline, or run them as we would like to run before, and just bring the things back as we were. And we can take snapshots of the state of our cluster and store them in etcd. You know, it's stored in etcd, and you can take the snapshot, and we can store the snapshot anywhere we like, and we can restore from the snapshot. So that's fine, that's okay. But how about you've lost all, you know, like what about the configuration files, your Docker files, your YAML files, your deployment files, services file, ingress files? I think one of the things I'll this is just by passing, I'll just mention a couple of things. Because everything is in etcd, you don't really need your files, right? Because everything's in etcd. The only thing perhaps you might need is your, once you've restored, but you won't be able to fully restore the limitations that we were talking about. So one of the things that can help you save your files is GitOps, right? So I'm sure you all have heard of GitOps and how it works. I'm just going to mention it's kind of back some sort of backup, but not really. But so I think I should just do an honorable mention of GitOps. So let's do this. Let's talk about so what GitOps is. So GitOps is what you do is you use infrastructure as code, which is what we were doing before. And what you want to do is you want to save everything in Git. So that means your configuration files, your cluster files, and your infrastructure as code files, your state of the cluster, everything gets stored in Git. And then what we do is you automate everything. So this work comes from our friends at Weaveworks, and this GitOps stuff is quite famous. One second, just cool. And then and what we can do is we automate everything.
One thing just before that, quick question about any tools. Would you recommend any tools to encrypt etcd data on rest after backup?
Oh yeah, so that all depends on, so depending on where you're storing your backup. So imagine you might be storing your backup in, let's say in one of the buckets. Let's say you're storing in a bucket somewhere, and you're using, I don't know, some key management encryption. It's a normal file. So anything you do with the encryption, any of the processes that you currently use with encrypting your files, you can still use them. So none of that stuff changes. So imagine if in Kubernetes you're using key management system to encrypt your secrets or anything like that. You can use the same tool to be able to encrypt. There's nothing specific about etcd file to be for encryption. I think, in my opinion, so you can't just use anything you like. I hope that answers your question. I think that was that. Are we good? Let me know if I've answered the question. But I'll check if there's any specific tools and I'll ping you later.
Yeah, no worries.
I think it's just, in my opinion, it's like a normal file. Treat it like a normal file. Any of the tools that you're using currently for encrypting your files, you can still use them. So what we do is we automate everything. Cool. So what that means is, in GitOps, what that means is you take your configuration files, you make a change to your configuration file if you wanted to, and you store that in Git. And then eventually what you want is that thing to get deployed into a Kubernetes cluster. So, what we want to do is take our deployment file and deploy in a Kubernetes cluster. And usually when you deploy something, we have two options. We have push or pull. And push is GitHub, a pipeline gets triggered in GitHub that does a kubectl apply -f onto a Kubernetes cluster. But what we want is we want a pull-based operation. What was that? Oh, I think I'm this thing. There you go. There's some slides we're missing. I think we're good now. What we do want is a pull-based operation. And what we want to do with the pull-based operation is we have a Kubernetes cluster that's running, and the cluster is talking to GitHub and pulling information and polling for information every 5 minutes or so. So instead of GitHub pushing it, the Kubernetes cluster is pulling the information. So we have an operator, which is something that's running in a Kubernetes cluster that's executing some logic and pulling what's changed in the Kubernetes cluster and applying it to the cluster itself. And what that allows you to do is stops you from having any configuration drift. If anybody deletes your cluster and you bring the cluster back, the cluster will talk to GitHub and say, oh, what am I supposed to have in the Kubernetes cluster? And it'll see all these files, all these YAML files, all the charts that you're supposed to have. I'll say, oh, I'm missing these things. I'll take those files and apply them on the cluster. So it kind of gives you some of that backup, right? So it kind of gives you some of the backup information. So it's a pull-based operation. So all changes go via Git and GitOps, and everything is audited. So if you wanted to go back to a specific version, you can just roll back to a previous commit. And when you roll back to a previous commit, check into Git, it will trigger it. It will get triggered from, like, next time the Kubernetes cluster pulls and to pull some information, it'll say, oh, a change has occurred. Let me go and pull this information, apply it. What else? I can roll back anything I like if I wanted to, and you only have to do via Git. Everything is good. But what GitOps does give you, we have to do some special work for data. And let's talk about databases, right? Let's say if you have databases or any services with persistent data, we need to handle them differently. And you can use GitOps to manage the changes. Let's say we have a database. You see, and you need to change the schema. But if I need to change the schema, I have to write the specific code that goes with to change the schema. I have to write that framework or implement that framework that actually does it. So in order to manage data from GitOps is a little bit hard, and you have to do the specific work. So what we got is, so far, let's take stock. We're halfway through, and we've got a few more slides to go through. We'll talk about some of the other options as well. So what we've got so far is we can roll back our infrastructure if we wanted to, and we can take snapshot of etcd, and that will give us a lot of things, but not everything. We can't get the state restored from it. We can only get like the pods that are running in and all that sort of stuff. If we wanted to get configuration files back, we can get the configuration files back if we were just checking them into GitHub, right, or source control of any kind. Or perhaps we can use GitOps to bring some state of the cluster back, because the state of the cluster is stored in GitHub, and we have a cluster that's running a special pod in an operator form inside the cluster. So you check out some really cool projects like Flux from Weaveworks, and that's a really cool project, and Argo CD. And all that will allow you to do is, if you install that in your cluster, you can attach it to a GitHub Git repository, and you can pull all the information and deploy on your cluster. So we've done all of that stuff. And next, what we're going to do is look at images. So, oh, why is that there? I wonder why. Don't forget to subscribe to my channel. Salman Iqbal. I just like to take a break.
It could be any page. It could be any page. I mean, it just happened to be this one. By
This
the
is
way,
happened to
Salman
say.
will be speaking next week in Kubernetes Community Days UK. Check it out. Also want to be there as well, just by accident.
Just by just by accident. Just by accident. Well, how are we doing for time, Bart? We doing okay?
Yeah, you're doing splendidly.
All right, cool. So I just would like to mention about container registries too, because one of the things that you can lose is the images. Let's say you are, your Kubernetes cluster is running your workloads. Where does it get your images? Or your container images? It gets them from a container registry of some sort. It could be Docker Hub. It could be it could be AWS ECR. Whatever you're running, you could use one of the managed container registries, or you can create your own container registry if you wanted to. You could create one on. I've got this JFrog container registry as well. So we could be using container registry from there, and all our images are getting pushed onto there. I think one of the things that we should look into is every time you create a container registry, depending on what kind of registry you use, and it's a good practice to deploy something which is like geo-replicated, perhaps in multiple regions, because you could be deploying your cluster could be running. You could have a cluster that's running in different regions, and you could be deploying containers into multiple regions. So you can do this geo-replication just to make sure everything gets replicated across different in the registry across different regions. And even if you're let's say you're serving local users, it could be, but you can basically enable some geo-replication as good practice to perhaps minimize latency, but also give you some of that backup. If you lose the container registry in one region, at least you have the container registry in another region that can let you pull the images from there. Now, that's fine. That all depends on what kind of container registry you use. And you can also automatically, and depending on what kind of container registry you use, like for example, JFrog, allows you to automatically and periodically back up the entire of your container registry system. And what the backup system does, it creates a timestamp directory in target backup, directory wherever you want to keep it. So you can basically restore. You can do a restore system backup. You just basically need to import it now. And if everything goes bad, you can still restore it from your Docker files, but you just have to go back to the right time, right moment in your container, in your GitHub repository, and go back and roll it back from there because the code has moved on. So talk about images, we talk about configuration files, we talk about etcd, talk about infrastructure. What about databases? How do we do a backup of database? But let me ask you all a question, and we'll answer it together. But please, I'll be interested to hear your opinions. Shall I run a database on Kubernetes? Let me know in your chats what you think. Let me know, Bart, what you think. Should we run a database on Kubernetes, Bart?
Yes, we should. Do it.
All right, so let's see. How do we run databases in Kubernetes in the first place anyway? So I mean, we've seen a lot of growth of this. Let's call it the application layer, right? So we've got this application which is stateless and everything's running, everything's working well, and the data layer of our application is starting to get a lot more traction now, but is not as the development is not as fast as with stateless workloads. And it's not surprising because containerized workloads inherently have to be resilient to restarts, scale outs, virtualizations, or any other constraint. There you go, learning fun. And I agree with that. Yes, you can inform a stateful sets. And we'll talk about that in a second. So if you run databases inside Kubernetes, you need to make sure you pick the right kind of technology. And we'll talk about that in a second, because containers have to be resilient to restart, scale out, and all that sort of stuff. So handling things like state, let's say database, and make it available to the application layers, and redundancy of the database can have very specific requirements. How do I make sure the database is redundant? This could make it a challenge to run a database in distributed system. For example, if I have MySQL and I scale out multiple instances of MySQL in my cluster, I have a deployment of MySQL that's running inside the cluster. It's a very crude example. I can do a replica from 2 till 3, or is one replica running? I can scale out to 2 replicas. How do I sync the data between the 2 MySQL instances? It's a little bit tricky, right? So that's why we'll talk about in a second. But Kubernetes is great, right? We get a lot more. There's some good stuff to be had from Kubernetes. If there was a stack that I can bring up rapidly, I can do that in Kubernetes, right? I can start a container really quickly. If it crashes and if it's deployed as a stateful set or deployment or whatever it is, it can restart the server. Beautiful stuff, right? I can do health checks as well, right? So why not? Why should we not? So what we want to do is, we want to treat data infrastructure the same way as we treat the application stack, right? That's what we want. It should be the same, like should not be that complicated. And what we want is we want to make sure we use the same tools for databases and applications and get the same benefits as application layers in the data layer, so we can rapidly spin up. So if you need to run databases, we specifically talk about that. We have basically, broadly speaking, 3 options. Broadly speaking, 3 options. One is fully managed, and that's what people call a low ops choice. Russell says you can if you have your own DBA. If not, then it might be better to pick a database as a managed service. And I 100% agree with Russell. Bart is not going to love this stuff, but I'm with this on Russell. What you say?
I respect Russell. I respect that. I'm sure he has his reasons. That's fine.
I want to know your reasons in the end. But so basically what we got is, at a very high level, we've got 3 options. We got fully managed, which is low ops. You let the cloud provider handle any of the maintenance tasks like backups, patching, scaling. And as a developer or an operator, I don't need to mess with them, right? How do I do a backup of this? How do I do an update of this? I don't need to do any of that. All I can do is just create a database, build my app, and let the cloud provider scale it for me if I need it. So I can focus on what I need to do, which is write the business logic, right? We need to be able to write business logic, and it all depends on what kind of skills you have. And I completely agree with Russell saying, if you got your own DBA, maybe it's possible. But what we want to do is focus on writing logic. It's kind of like, I don't know, having your own car or having an Uber. So one of the things this fully managed option does not give you is you might not have the choice of the database that you'd like to run is getting provided by the cloud provider. Maybe the cloud provider doesn't have MySQL, a specific version or an extension or an exact flavor of the database that you want. Or you can do a DIY on a VM. You can grab a VM and you can basically take a virtual machine. You can take whatever database you want to run and you can install it. This is perhaps what people might refer to as full ops option, where you take the responsibility for building your databases, building your machines, you're scaling it, managing reliability, setting up backups, and more. All of that can be a lot of work, but you have all the databases that you can use. You got all your flavors at your disposal. Or what you can do, this is, I can guess, Bart's favorite option, is run database on Kubernetes. Is that right, Bart? Is that your favorite option?
That is an amazing option.
This, in my opinion, is closer to the full ops option that I talked about in DIY, or depending on the choice of database you pick, which is very important. But you get a lot of options. You get a lot of benefits. You do get some benefits. I completely agree with Russell. Russell doesn't like fixing database issues in the middle of the night. I don't like fixing any issues in the middle of the night, let alone database. Databases are harder to manage. Completely agree with that. I'm sure Bart loves that stuff. Bart is cool with that. He can wake up at 2 a.m. and sort it out.
I don't sleep. I don't sleep. I have no weekends. I have no holidays. I dedicate all of them to working on broken databases.
So basically, this is closer to a full ops option, but you get some benefits in terms of automation. Kubernetes provides to keep database up and running. We'll talk about if something crashes, it gets up and running. So, for example, it is important to remember that pods are transient, and so the likelihood of database application restart failover is high. and also some of the more database specific administrative tasks, such as backup, scaling, tuning, are different due to the added abstraction that comes with containerization. So there's a bit of a there's some added complications. So how to do on Kubernetes, we'll talk about that in a second. Learning fundamentals is exactly what we're going to talk about. So when you do go down, you might say, I still want to stick to Kubernetes because it does give me some options. When you're choosing to go down the Kubernetes route, what you need to do is you need to think about what database you'll be running and how it will work given the trade-offs that we previously discussed, because you still have to manage all those stuff. Since pods are mortal, and the likelihood of basically failover is higher or than a fully managed database, because something can happen. The pod is running in a cluster in the node, and somebody's running a pod within the same node, and they forgot to write they forgot to add quota limits, and it took over all the memory of the node, and there's not enough memory. There's starvation of memory. Lots of queries are coming to the database. The database pod cannot manage, and it starts crashing. It's easier to run a database on Kubernetes if it includes concepts like sharding, failover election, replication built into its DNA. So, stuff like Elasticsearch, Cassandra, MongoDB, those are a lot easier to run in Kubernetes than our standard, I'm saying standard, but then let's say MySQL or Postgres database. So this is something that you should consider. Like Elasticsearch, Cassandra, MongoDB, they're good. And actually, there's many open source projects that provide custom resources and operators to help maintaining the database. Custom resources is like any other resource in Kubernetes. Like you have a deployment, you can define a type of database. You can define a type of MySQL database, and you can do kubectl, create me a new database, and it'll create you a new database inside Kubernetes cluster. That's powerful using from kubectl. You can define those things, and those operators exist. Quite a few of those operators exist, and I'm going to mention a couple in a little second. Next, what you need to do is you need to consider the function that database is performing in the context of the application that you're running for the business. So, if the data is storing more like caching layer than actual, storage data, then maybe is better fit for Kubernetes. And, the data layers of that type are typically a bit more resilient built than into applications. So, it just makes a bit of an overall better experience. Finally, you have to be sure that the replication modes available in the database are, work fine. For example, asynchronous modes of, can lead to data loss because you could lose transactions. So basically, what we need to do is be sure of understanding what we're getting into, what we need to do if we incur data loss, and how much of that is acceptable in the context of our application. So, shall I run a database on Kubernetes? And I think the best answer that I got when I was researching this a little while ago is from this diagram from Google. And we just talked about this being Kubernetes friendly. Some database types are a bit more Kubernetes friendly than others. So all it says is, does my database have Kubernetes friendly features? No. If that's not the case, on the left-hand side, is there an operator that can help? So if there's an operator, it's basically somebody's written some custom logic to help with that, to help run the database in your cluster. If it doesn't exist, if it exists, it's a lot easier. If it doesn't exist, can you write your own operator to deal with that? Or if the workload that it puts on you to be able to manage that cluster, is that acceptable? Then yeah, run it wherever you like. Run it on a VM, run it on Kubernetes. But the path of least resistance in all of this, like with everything else, is pick a fully managed database. So if you do want to deploy on Kubernetes, how do you deploy? Imagine you look at that decision tree and you decide, yeah, we're gonna go with Kubernetes with database on Kubernetes. You can use stateful sets to deploy databases on Kubernetes. And stateful sets is just like another object in Kubernetes. It manages the deployments and scaling of pods. But what it does additionally is kind of like deployment. But it does additionally, it guarantees the ordering and the uniqueness of the pods. And also what it does, it basically makes sure they are basically gives sticky identity for each pod, and you will be able to it will get you persistent storage, so you can store the information that's whatever's happening in a pod in that storage. So you can deploy databases as stateful sets. And to answer the question, how can you deploy databases and on Kubernetes, is they have a number of options. You can either use operators that already exist, so you can create the CRDs on your cluster, or you can take, that's probably one of the options, and I'm going to show you a couple of options in a second, or you can create a stateful set, and there's plenty of examples out there that allow you to do that. And stateful sets, give you basically give you a bit more stability. And what you can do with stateful sets is you can store the data on persistent volumes, and you can decouple the database application from the persistent storage, which is, there's two things, right? You have the database that's running and the storage itself. So when the pod crashes, as in like the database application, not the data is still there because stateful sets gives us this persistent volume. Additionally, when the pod is creating a stateful set, it keeps the same name as well. So you have a consistent endpoint to connect to. So if the application is talking that, like pod name is exactly the same. So that's one of the options of running the databases. So, or what you can do, if you don't want to run a database that perfectly fits a model of Kubernetes friendly database, there's, if it doesn't exist, you can go down the operator path. So for example, MySQL or Postgres, and an operator is just a piece of logic that sits in your cluster that behaves on something. So you define a custom resource definition of a new type, define a new type of your cluster, and then, for example, MySQL is going to be a new type of your cluster, and then you can say, kubectl, create me a cluster, create me a MySQL database, and an operator is just logic that's sitting in, create you a cluster. There's a couple of operators there, just put down. You've got the Oracle MySQL operator. It's kind of pretty easy to install and get it up and running, or you can run, if you run PostgreSQL. These are two that I've used, and that's what I've put them up here. This crunchy data. Now there's many more. And if you got a different type of database, definitely have a look at some of these operators. How are we doing, Bart? Are we doing okay?
This is good. Yeah, good.
Good, yeah. You still want to run databases, yeah?
I'm not changing my mind. I'm even more convinced. I'm going to hire Russell to be on my team.
Yeah, exactly. Well, we said pick the right database, and you'll be laughing your way towards.
I understand. There are databases and there are databases, so it makes sense.
Yeah, exactly. You pick the right database, and you're good to go. And to be honest, it gives us lots of options. So that's all good. So how do you back up? If you're using an operator will give you some options itself. So the operator itself will have a different type on there. You can be able to create a backup. Again, that depends on types of operator. Or you can write your own. If the operator doesn't exist to give you backup, you can write your own operator. You can write your own logic and start taking backups. And these, depending on what they are, what they'll do is they'll attach to different sorts of storage. You might want to store the backup of the database in GCP Cloud somewhere in a bucket or something like that. So you can do that. And you can write your own scripts and run them as cron jobs if you wanted to. Let's say you do a MySQL restore, you can create a container yourself with the script that runs, that executes and stores it. And you can run them as cron jobs, which is just jobs that run on a schedule, and then take a backup and dump the file somewhere you like off that backup. Or you can use other tools like Portworx. I'm not going to go because there's tons of tools. I really don't want to go into a lot of tools in here, but I just wanted to say that you can use a tool that allows you, for example, if you have MySQL cluster that's running anywhere inside a database, inside Kubernetes cluster, or even outside, it gives you this ability to be able to configure, take backups, and restore them. Could you please share any links with respect to Postgres databases on Kubernetes? Yes, we will definitely. If you give me a second.
Yeah, and we actually have blogs, and we have plenty of videos about that as well too here, so I can definitely.
There you go. We got Bart. You are at the right place to ask this question.
This is my job. This is my job.
Bart's got you covered. This is to be honest, I'm not really bashing running databases on Kubernetes. If you pick the right choice and your application, it basically, if you can live with what it gives you, and it gives you some benefits, you should definitely go for it.
Yeah,
depending on the use case,
regarding Postgres specifically, I'll link this video right here that we had in our KubeCon co-located event, and I'll also link his Twitter because Alvaro, if there's anybody who knows Postgres and Kubernetes, it's definitely him.
There you go.
And he, if you reach out to him on Twitter, if you have questions, or also in our Slack, he will definitely help you out with that because he is very, very passionate about this topic.
No, it's good. Like if you have an operator that can help you with this stuff, the running database, it makes your job easy. It's like automating all the operations stuff that you need to do. If there's one that exists that can do it, and and to be honest, it just keeps getting better and better, right? So this is not, we're to a point where people are running databases in production. Not me though. In production, Kubernetes.
Give it time.
But yeah, it depends on the use case, and depending on what kind of options you have, you can depending on how you're doing, you can restore from the backup. So let's take stock. I think I've been talking a lot. Let's take a stock of where we are. So we've got infrastructure, we've got etcd. We can take configuration files, we can take backups of those and recover from those images, and databases as well. Like if they're running in Kubernetes, we can take backups, right? We saw a few options here. In our case, depending on how you're running it, you have options of off either using if you're running your database in Kubernetes, you can the operators might give you options, or you can write your own scripts to be able to create those backups and dump them where they are safe. So last thing here is volume snapshot. So we got some volumes now. Let's just forget about databases in a second. But at the heart of it, the file where it's living, even if it's a database, is living in a volume. Or if an application is writing, it's living on a volume. It's living on a volume somewhere, depending on whatever volume it is, doesn't matter what volume it is some volume somewhere it's living. And what happens is you can create snapshots of volumes. So many storage systems, like let's say if you use GCP's persistent disk, or Amazon Elastic Block Storage. I keep going back to Amazon Elastic Block Storage, or you got or even on-premises storage systems. They give you this ability to create snapshot of persistent volume, depending on the type that you use it. So you can create these snapshots, and you can do them regularly, and you can store them. And what they represent is a point-in-time representation, point-in-time copy of the volume. And you can take that, and you can either create you can use a snapshot, and you can either provision a new volume from that snapshot that you created, or you can restore an existing one to a previous state. So you had an existing one and it ended up in like a weird state. You're like, oh, I need to go back to the previous state. You take that snapshot and you can do it. And this snapshot is actually a Kubernetes object. And the way you do it is you have a YAML file, yet again. I've got a volume snapshot type. Kind is volume snapshot. And all I need to give it is a persistent volume claim. So we've got persistent volumes, and all persistent volume claim is when it's like an abstraction on top of persistent volume, is all it says is give me this much storage, and all the application, all the pod refers to is a persistent volume claim. And at the end of the day, the persistent volume claim is attached to some volume that's running anywhere. And in this case, what we can do is you can say, yo, take a snapshot of this volume claim. And if you look at the last line, it says persistent volume claim name, PVC test. So what I can do is I can take that snapshot and I can store it wherever I like. So whichever volume it is, it's going to go and get stored in. So if you look at this, how do I use this, right? So let me just go back. How do I use this? How do I use it? How do I restore from this the snapshot that I did, right? So I can go to my persistent volume claim file. And if you look at the last line, all it says is 10 gigabytes. So all I need is 10 gigabytes of storage. And we've got some access modes in here, different type. All this is pointing to is the volume at the end of the day. I can have it blank. But if in the data source, I give it a name, the snapshot name itself, it will take that snapshot and it will basically bring it back. So a persistent volume claim will now be backed up from, will now be restored from the backup that we created previously. I hope that's clear. So it's a few things we discussed, right? We discussed a lot. We talked about infrastructure, how we can get that back, etcd, how we can get that back, if anything goes wrong, configuration files, how we can get those back, databases, how we can get those back, persistent volumes, how we can get those back. That's a lot, right? That's a lot that we have to do to get back. But would you agree or would you not agree? Is that a lot to do
It's
with?
a lot, but it was so well explained, and now it's really easy.
Okay. What if it was a little bit simpler, right? Let me give you one more thing. Let me give you one more thing. And unfortunately, we won't be able to see the demo because my billing account in GCP got suspended today for some reason. But I'm going to point you in the perfect place where you can check it out.
But
What if
as
it
a
was-
community, we value your transparency that you will even reveal personal finance details. That's great.
Yeah, he's getting the account. I don't know what happened. I changed my credit card
It's all
expired
good.
yesterday.
It's all good. It's all
But
good.
you know, like anyway, it is what it is. But I'm going to
Yeah.
point you in the right place, and you can check it out. So, what if it was this simpler? What if it was a little bit simpler, where I can just basically run a couple of commands? It will take me back to exactly where I was back in time. Maybe I can just run one command and say, "Oh, take a snapshot of not just the application itself, but also the volume," because that's the biggest pain, right? The volume we saw, we can take these snapshots. But imagine you got like hundreds of volumes running in your cluster. How are you going to take snapshot of each volume? It's hard to do, right? Like you need to remember: have I taken a snapshot of this claim? Have I taken a snapshot of this claim? It's quite a lot to do. So there's projects. There's many projects out there. I'm only going to talk about the project that I think is very cool. But there's many. Valero. I'm sure you've had lots of talks on Valero, Bart.
That's correct.
Yeah, so there you go. Bart can probably send you a link on demos of Valero and stuff like that. But if you have any links, please throw them in the chat. You know, I'll appreciate that. So what does Valero try to do? Valero give you? It's basically you have a cluster, and on the cluster you can install, some operators. So some custom resource definitions in your. So you got some extra pods there running in your cluster, and it gives you ability to recover from disaster. And you know you can migrate cluster. You can imagine if you're in one cluster, and it can take you. Valero can help you port you from one port your resources from one cluster to another. So as long as you point each Valero instance to the same cloud object store, and the way it works is in Valero, which we would have seen. But oh, perfect! Thanks, Bart, for that. Bart's shared a video now, and what you can do is you can basically point Valero to. You can create a bucket anywhere you like, and you can install this on in the cluster, and you can point that to a bucket. And every time you take a snapshot, it takes a snapshot and stores it in that storage of your kind, whatever you pick. And the scenario assumes that what we can do is we can bring back, or you can do like on-demand backups. I can just go in and create me a backup if I wanted to. I can just run a command and say, create a backup now. I can do scheduled backups as well. So Valero treats store object storage as basic, I can, if I wanted to do a scheduled backup, I can do those as well. Valero also treats object storage as source of truth. It continuously keeps checking to see if the correct backup resource is always present or not. And if it's not formatted correctly, and it's very easy to use. It'll just make sure Valero synchronizes the information from object store to Kubernetes. And definitely check out the links that Bart has shared. I think that's more than enough for for this. So let me just quickly show you one thing here. What Valero allows you to do is basically you have this backup control that's running inside your cluster, and you're creating once you create each Valero operation, for example, the on-demand backup, scheduled backup, or restore is a custom resource. So you can in a YAML file you can define it. And you'll check out in that video. And and basically we've got some operators, controllers running inside the cluster that takes care of the process of performing the backup, doing the restore, and doing all the related operations. But all you need to do is you need to create a bucket or a storage place where we can store all these backups, and you can take backups of the backups. So if you have a storage bucket, you can take a backup of that just to make sure you don't miss anything. So let me just do a quick summary. If you want to check out Valero, check out the projects that Bart has just shared. So let me just do a quick summary. There's a lot to take in. Hopefully, it was it was easy to digest. If you lose your cluster, there's quite a few things you have to consider. How you create your infrastructure, use infrastructure as code. Maybe you need to take etcd backups, right? So if you need to take etcd backups, take them regularly. But if you're using managed service, you don't need to worry too much about them. What about your configuration files if you lose them? Well, if you use GitOps or if you're using any source of source control, you can stick them in. Any other images, container registries, you can use those. All the databases, if you want to use a database, we talked about if you should or you should not use a database. Hopefully, we talked about you have options, and some are very good depending on the choices you make. You can run them, or you can be free of waking up at 3 a.m. in the morning and let somebody else take care of it. And or you can take snapshots using persistent volumes. But more importantly, you can use some of these projects like Valera to do the work for you. And Bart has shared some of the links. Before I finish, I'm going to throw in this link again. There's a Kubernetes calculator that LearnK8s have launched today. Basically allows you to figure out how much you pay per pod, depending on how many pods you want, like this. It's an interactive one. I'm just going to increase the size and stuff. But yeah, so I am going to share the link of that calculator.
I already did. You're all good.
Perfect, man. Excellent.
No worries. Yep.
Excellent stuff. We got the link already. Also, please don't forget to like and subscribe to my channel. I don't know if you should I throw the link to my channel in this case.
Yeah, do it.
There's some new videos coming up. I think maybe you do some data videos I haven't done.
Oh yeah, we could. No. Anyway, like, subscribe, share, create a fake account, like, subscribe, and share with that one too. Hack your family's accounts, get on there, like, subscribe, and share. Do it. As you can see, though, seriously, like all jokes aside, super down to earth, no BS, no heavy sales pitches or things like that. This is really, really good quality content. And not only the people that have been watching this have been enjoying this, but I'm sure the folks that are going to be watching this later, there was so much that was covered. That is also a factor, but you did it in a way that wasn't overwhelming. Slides were really clean and concepts very well explained. Even some things where you said as well too, folks might be familiar with these terms, but there's a lot of terms that you have to be familiar with. So I think it's always good to go back and take a look at what you're talking about when you're referring to things like CRDs and etcds, because a lot of times these terms just blur together and get kind of confusing. So anyway, we're going to be having you back.
No, definitely. I got one more slide here, which is I really want to thank all of you for welcoming me here. I really appreciate that, Bart. You made me feel so welcome. You have an amazing community, all the stuff that you do. And please keep those raps coming. I don't want to, every week I wake up, I'm like, what's Bart rapping about today? Let me just check this now. It's like Spotify, right? It's my Spotify. Just go on there. And you have really awesome people in the community, and you've really grown it amazingly well. And I really appreciate the love you've all shown me. And hopefully people found it useful. I know some of it was quite high level, some of it was a little bit more detailed. But I wanted to give I lost it. How do I get it back? There's quite a few things to consider. It's
brilliant because, like you said, these things are going to happen, and so it doesn't mean that you have to live in fear. Be prepared. Absolutely. And the other thing that you said as well too, way early on, that I think for folks that arrive maybe a little bit later, extremely practical wisdom, particularly someone who's spent a lot of time in communities, as such as yourself, is that understanding that while there is a technical side, the people side is at least, I wouldn't say 50%, I'd say more like 80%. And makes a lot of these problems much easier to deal with by interacting with folks that have dealt with this stuff before, knowing that when you do have a problem like this, you can tweet somebody, you can tag somebody, you can contact somebody in Slack, say, hey, this is what I'm dealing with, and people will be more than happy to jump in. That's what community is about. So I think it's really nice to hear that from you, particularly as someone who's been involved in the, organizing stuff in Wales, participating next week in the KCD UK. Once again, everybody definitely check that out. Free event, lots of great talks. Can I get you to stop sharing your screen really quickly?
Oh yeah, of course. Yeah, I'm gonna stop. Yeah.
No worries. No. It's not so that I have to see myself. I don't want to see myself.
No, there you go.
Okay, let me. I just gotta get this up here really quickly. We're getting some great feedback in here. Great feedback.
Thank you. Thank you, everyone. I really appreciate it.
But the thing is, like what coming from the rap world, like game recognized game. So when you get that nice feedback from people, it means that they really were paying attention. They value the content that you're putting out there. And you know that your fan base is increasing, expanding, which means it's never too late to start your music career, Soulman.
That's your thing.
But I love the name. It's such a good name. So I'm going to share my screen real quick. So while you were talking, as usual, we had our amazing graphic recorder, Angel. Can you see my screen?
Oh, wow,
Screen?
that's cool.
Yeah.
That is unbelievable.
So yes, he was drawing all this. He was drawing this to get a visual
Oh,
depiction
yes,
of the stuff that we were talking about. I think it's really, really nice.
Wow.
Put in the context of, imagine that you're on a boat.
Oh, this is amazing.
On your recovery boat. So Angel was drawing this while we were talking, and you obviously did a great job of explaining things because he made his job easier. English isn't his first language or his second; it's his third language. So it's always a good sign, that there's a connection there, and very, very easy to put this visually. So anyway, Salman, it was wonderful. It was wonderful having you with us.
Thank you so much.
I was already putting in the chat that we definitely have to have you back. We just got to find the excuse when. Hoping that I'll be able to cross the channel and get over to the UK at some point. If not this year, definitely next year. So hopefully be able to see you in person as well. Thanks everybody for coming out. Salman's really easy to find, as you saw on YouTube, on Twitter, extremely active, doing lots of stuff in the community. So feel free to reach out. Amazing training, skills, all that. So yeah, that's all the time we have for today. Thank you very much for joining us today, Salman. Thanks everybody else who's out there. As you, once again, sign up for KCD UK next week. Check out our co-located event we're going to be doing in KubeCon, and we'll be seeing you soon, man.
Thank you very much. Thank you.
Take care.
Thanks.
Cheers, everyone.